Hello all, this video is a part 2 video of the Open Autoware Foundation series. So today we are going to discuss about Open Etiquette. So before going to Open Etiquette, let me just give you a brief overview with respect to how the Autoware's open source autonomous driving stack works in reality. So here as you can see, this is the complete autonomous driving software stack which is running on ROS2. It has been created in such a way that it is independent of the vehicle type or the electronics hardware which is using, and the best part is it is completely open sourced. Now, if at all you see, there are in total 7 subsections over here, which are basically the planning, perception, control, localization, sensing, map data, and vehicle interface. So let me simply explain it to a person who has not much of an exposure with respect to autonomous driving. So in autonomous driving, what happens is the vehicle on which multiple sensors are mounted receives the information from the sensors, which is basically this sensing module. Once the information has been received, there is this vehicle is basically on a particular location. Okay, so the location has a inbuilt map already. So you have the map data of the vehicle, and the vehicle is in a specific location based on this map. Like, mm, you have a map of a uh, city block, and you are standing at the junction of this particular city block. So localization is basically telling the vehicle where exactly it is placed with respect to the actual map. Okay, so now we have the sensors. Sensor data is basically collected, uh, then a perception module kicks in. So perception module keeps track of it. It basically detects the various objects in the environment. It tracks the objects. Say a person is crossing the road, then it is detected as a person, and we are basically tracking it that a person is crossing the road, and we are basically predicting that okay, fine, so this guy is crossing the road, and his next movements will also be like crossing the road, and he won't jump. So these are some of the prediction models which basically kick in. There are many other perception algorithms like segmentation and many things. Okay, now that the perception has detected the various objects and it is tracking it, basically the car which is at the point A has to go to point B. Okay, so the path will be calculated, and based on it, the path planning will be done based on the feature which it is operating on. Like if at all it is a full autonomous driving, it is crossing an intersection. It is the job which is taking up is basically going from point A to point B by crossing the intersection. Say if at all it is a valet parking scenario, then there will be different planning algorithm for that. Say it is lane following, it is something else altogether. Now, based on this particular path planning, the control has to be given to the vehicle interface, saying that okay, fine, now you have to go at such a speed with a such steering angle so that you can safely cross this particular intersection. Okay, so these are the individual building blocks which are basically what the Autoware autonomous driving stack is all about. Okay, now with this being the case, we just move on. Now, in that case, if everything is there, why do we you even need the open etiquette? So, open etiquette is basically uh, taking in the inputs from the Autoware Foundation. It is taking the inputs from SOFI, eSync Alliance, and MIH. MIH stands for Mobility in Harmony. So Autoware Foundation, which I have explained above, is the open source implementation of autonomous driving. So that's it. Sophie, it is with respect to running the cloud workloads on, I mean, like the Dockers and other cloud native applications on the automotive hardware. I have explained this in a previous video. I will link that in the description. Please do have a look. eSync is basically a alliance where the 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 explanation is with respect to specification for OTA updates in the automotive vehicles. What it means is like how do you it is kind of a specification sheet using which the management of updates for an automotive applications can be taken in. And MIH basically is the open specification for integration and verification of automotive functions in an electric vehicle. I'll make separate videos explaining the importance of eSync and MIH separately. So, OpenEdicate is using all of these four alliances and trying to make this OpenEdicate compatible with the software-defined vehicle architecture. Now, this is basically the OpenEdicate's architecture or OpenEdicate's blueprint based on the Sophie's first blueprint which was released. Okay, so as you can see, this is the Sophie architecture. You can see my previous video will get an idea with respect to this. Here, evolve stands for the Sophie reference implementation, which is a custom Linux distribution created using Yocto. Okay. Now, the earlier modules which you have seen over here are split into microservices, uh, three or four of it. Okay. And the OTA part, which I have explained in the eSync, has been put as a part as a separate agent which is running next to this one. So this is the reason why the OpenAD kit is an implementation of the Autoware stack using the Sophie's first blueprint. The reason why this is necessary is going forward, all this uh, vehicles will be software defined. So in that case, the entire Autoware stack cannot run as a single monolithic application. For that, it has to be a microservices architecture based system, so that the updates for a specific module like perception or for a specific module like planning can be implemented. As Sophie is the uh, kind of the main organization which defines how the container should be running in an SDV. OpenADKit, the Autoware has incorporated their software in this format so that any OEM can directly or any supplier can directly pick this and they can reduce their time to market. So this is the first version of the OpenEdit. Here we do have the workloads, various workloads, as I have explained with respect to the vehicle system, simulator maps, and everything, which is running on an ARM system. So this Sophie is on. So this OpenEdit is implemented on an ARM hardware, and to correspondingly see this simulation in our host machine, which is an x86 machine, the visualization workload is running separately so that you can visualize it. If you don't want to use your system and if you directly want to visualize it in the web.auto, which I have explained in the part 1 of this Autoware series, you can even use that and you can do it. Okay, so this is basically an ARM hardware and this is an x86 hardware. Thank you for your time.